Super. So it's working already.
Hello?
I will introduce you guys and then. So welcome all of you. This is the fascinating session about AI. Everyone is talking about AI. I'm your host, Supratik Banerjee is my name. I will directly, without any further ado, call my first speaker, Markus Riedel.
Hello, ladies and gentlemen. So,
You can take your place.
AI is the topic of today. So, we are a small company out of Munich with locations around the world, quite expanding dramatically. Also, when we are in the market since 40 years. So, we are an enabler to the market. So, we are coming out of the microscopy area, so we know what a micron is, what a nanometer is, what even smaller in the biological application as well in the industry. The topic of automation is coming from microscopy as well as in industry. That's why we are here on the show. We are producing sensors. We are a sensor producer, and a sensor is an optic inside, is a camera inside, everything. And AI needs reliable images. And reliable images means the defects, the anomalies must be in the image. If they're not in the image, you can have the best AI, you can have the best neural network. It doesn't work if you don't see it. And in these markets with predictive maintenance, quality assurance, manufacturing processes, and so on, we've developed a very specific technology called Solino. The development started 15, 20 years ago in a university in France. So we were part of it. We always were the part in making the optomechanics around it, and now we are also doing the software. We have a big software team in France. We are producing our parts in Munich and developing the parts in Jena. And Solino is about using a specific technology called reflective transfer imaging, where we are analyzing the stray response of a product. Means we have a photometric stereo approach in having a dome with 64 LEDs. They are arranged in a circle, and out of this we are really, wait a minute, go back. And based on this we are analyzing the stray response. We wanted to go away from use a camera, use an optic, use an illumination, 3 different partners. You have to build them together, build your own software. No, plug and play. In some seconds, a result. And what is the result? We always start with an image. We even go a step further and saying our result is a picture or is an image with anomalies. In this example, you see what is the difference. In the image on the top, that's a very standard image that you're getting from a PCB. From a Solino, we can highlight an anomaly. We have more than 200 algorithms around to optimize the algorithms of Solino towards your anomaly. And because of the 64 LEDs and the way how we're doing, we are extremely robust about ambient light effects. That means if you have a reflection on your surface, it doesn't matter, because the stray response is the response of hue, of color. It's a scratch, it's a height difference. This is an anomaly, and every anomaly we can analyze. And all with the 64 LEDs, we are not missing anything. That's why it's one of the only technologies that is really able to guarantee 100% assurance of anomaly in the image. I'm not speaking about AI at that moment. But again, if you don't have it in the image, you can't analyze it. You can't fill in neural networks. You can't really detect the anomalies and make a decision making around it. And this enables, maybe not only with the image, but also with the anomaly map. It's a statistical map of anomalies. You maybe can go immediately, directly into the labeling, instead of label images and finding the anomalies in the image. And you see, when you analyze the reflectance of a sample, every change in the reflectance gives a change in the anomaly map that we are creating. We call this extraction of particular features. Extracting particular features means we give every feature, every anomaly, an digital identity. And if you have this digital identity, you can read it out. Then you're pure in the statistics, and then you're pure in the AI. So, but what we can deliver in the next step, the image is the first thing. That's what the people like. That's what the people are used to use their existing image processing tools or their AIs that they have or their platforms, whatever. For example, we on our booth have RoboVision now with us, assisting us in the platform businesses. But at the end of the day, every anomaly is a detected footprint in the digital space. So every anomaly for us is a value. And these what I show you here, all what you see are only the images. From the background, we are detecting the anomalies. The anomalies are in this extracted particular feature data structure. And out of this, we analyze by ourselves, based on different algorithms, to show the anomalies in an image. Because we realized only digital space, only numbers, the people are not so say understanding what it's doing. The people always want to know how to measure. How are we getting the results? That's why the images are perfect. And then you can imagine the applications are endless. So we as an Optor, our enabler, we are producing a sensor, but we are also assisting our customers to do the end application. We are willing to promote you, to promote your application. We are not concentrating on the end application, but we know what AI means, and so on and so on. An example, for example, was artificial diamonds. I told you we make 64 images, and each image is principally an image you can expect with a standard illumination. So you have the reflexes inside, something you don't see anything, because you have this stray response or no stray response. You have no light principally, if everything is diffracted. And then when you have such images, yes, indeed, it's much easier to go for an AI, to feed a standard platform, to do this detecting, this labeling. You see immediately that there's a defect, and then you are principally only in the labeling aspect, and you have a result very, very quickly. Again, a reliable image, and that's what we're saying for our products. We're not delivering the AI, but all our products are AI ready. And you immediately see what you get from value. That's only one processing about bullets, about these cartridges. The same in the electronic fields, especially the top right. It's a very nice example of BGA bumps on a semiconductor. In a later stage, as you see, we have a triangulation method. We have 64 LEDs. We know the angle. We are analyzing where the angle is coming from. We principally can extract a 3D map in a later stage. But why? Why not teaching a good sample and a bad sample? Every anomaly is in sight. So you're much quicker. It's a different approach to the samples. And then the things are principally endless. And you see the value, okay? Making 64 LEDs. And electronic market is a very, very nice market because it's scalable. We have these things available in different field of use, so that's 10 by 10, but 25 by 25, 50 by 50 spatial resolution with a 20 megapixel camera. So you can imagine what you can do here. And then you are really, really inside your application immediately. Don't take care about the sensor. Use it. It's coming with a platform, or we can deliver an SDK to build it inside. And then you are in the process, like here, Rugo test, okay? Roughness measurements or roughness classifications. Or, for example, we are in the metallurgical space here in saying, okay, so these welds, depending on the acids that are accused to. So you have always different types of samples. Doesn't matter for Solino. Solino always gives you a reliable image of the defects of here, for example, the difference in the welding. And then you can apply a standard image processing tool. Or you can say, okay, we do it for you. You use your existing platforms and so on and so on. So again, the applications are really endless for these Solino. Come to our booth. We are in Hall 10. So we have it together with Kunica Minolta now on a cobot system. you can have it on top on a robot arm, you can have it underneath. And for OEM versions, we are really able to make speed testing. That means a second or 2 seconds, 64 images plus processing with a 20 megapixel camera and the processing with the Solino algorithms. So we're really in the process speed now. And that's what the semiconductor industry is telling us. We are in the phase, the people love what they do, what we do. Yeah, that's it on the market, okay? Thank you for your time. Thank you for understanding and maybe open for questions.
Yes. Do we have questions? No questions, but I have a question. So one of the slides showed that the accuracy is like 100%?
100%, yeah.
It's really 100% accuracy.
Yeah.
And what about false positives?
The accuracy is in the image. The accuracy in that we have everything in our data set. The image, forget the images. The images are an extraction out of the data set.
Okay.
But in the data set, every anomaly is inside. An anomaly is an edge, is a distance, is everything. So that's the 100%. And what you do with the 100% is completely on you. If you make an image or you make an analysis out of it, that's the 100%.
Okay.
But we have everything inside, and that's it. You only have 1 or 2 seconds to get everything of your product inside the data space.
Okay.
And then we have the specialists to extract it, to make an image, and so on.
Yeah, and how can it, I mean, what are you working on right now that it will be even better?
The most thing that the people for the application is the speed.
Speed, yes.
But making 64 images and the processing with a 20 megapixel camera or even higher, you know what this means. It's bandwidth. These are the principal challenges for standalone things, for quality control, even for standard predictive maintenance. We have PCB boards. Okay, we have anomalies inside. We are teaching a neural network here. That's working fine. That's working perfect. And for most applications, work perfect. So, for example, we have a very, very big project about handwriting, analyzing a handwriting. So if somebody wrote the signature on a paper some years ago,
yes,
it's not visible anymore.
Yeah.
But the reflection is different because you have a different indent. So low reflective surfaces, perfect.
Okay, that answers my question at least.
Thank you.
Thank you for your presentation. I see the second speaker is not here,
Thank
so
you.
we'll just directly go to the third one.
Okay.
Thank you.
Thank you.
See you on the booth.
See you on the booth.
So the next presentation will be by Victor Smedby. How scalable vision platforms help to unlock lot sizes. Right?
Thank you.
I think they will. Donato you're here. Okay, so Donato is now here, so maybe we can, if you want, you're up now. No, right now. Okay. Or maybe you can take a seat, Victor. I have already announced his thing. I will just go back and say the third one comes second and the second one comes. But you can take a seat there.
Okay.
Can we just switch?
Looks perfect.
Perfect.
Scalable platforms across machine vision technologies unlock lot-sized one. My name is Victor Smedby. I'm a strategic product manager at SICK for machine vision. And I'm going to share this topic with you and how our platform SICK Nova meets modern manufacturing challenges. Today, I will first introduce a bit who we are at SICK and what we are doing with machine vision. I will talk about lot-sized wide applications and what kind of challenges they face. Then I will talk about our platform SICK Nova and how SICK Nova tackles a lot of these issues. So first of all, SICK, sensor intelligence with global reach. We are a roughly 2.3 billion euro sales company and have over 12,000 employees. About 1,700 of those are in R&D, so we are a fairly R&D heavy company. And we have 60 subsidiaries worldwide and really do cover more or less the entire world. We were founded in 1946 and we have our headquarters in Waldkirch in Germany. We are active in factory automation, logistics automation, process automation, and I would say that we're most famous maybe for our safety products and some photo switches and things like this. But I want to talk about machine vision. Because machine vision at SICK also has quite a long and rich history. It starts in 1985 in an office in Sweden. And you can see the first few years are filled with a lot of world's first. We made the world's first CMOS vision sensor. We made the world's first 3D smart camera in 2005. And then the 3D cameras is maybe what we have been most famous for, but we quickly expanded into smart cameras, 2D smart cameras. And you can see we made high-speed 3D cameras with color support. We've done robot guidance systems. And in 2018, we again broke the speed record with the Ranger 3 for high-speed laser triangulation 3D. In 2019, we for the first time showed our Inspector smart camera or vision sensor with deep learning embedded, and I think it's a nice parallel here to our shared German-Swedish heritage, how the German Chancellor Angela Merkel at the time and Prime Minister Stefan Löfven were at our booth checking out our deep learning running at our vision sensor here in the image. After this, we launched our platform called SICK Nova that I will talk a bit about today. And it marks a bit of a new era in machine vision in SICK, because this means that we try to bring everything together, all the technologies we have, into one umbrella where everything behaves the same and works the same. We keep expanding into 3D with the Ruler product in Ruler 3000 product in 2020. And with in Nova 2.0, we expand our AI capabilities with edge learning as well. So what have we done in 2024? Well, a big launch for us was the Inspector 830, which is an AI-centric vision sensor. We've released the Ranger 3 high speed for additional performance and color support. We introduced the Surface Plus technology for our 3D cameras, which lets you find really the surface structure extracted from the products. And we launched SICK Nova 3D for Ruler and LMS support. But I'm a little bit getting ahead of myself. I will come back to that later. So now, let's get back to the history of modern manufacturing and lot size one. Because how manufacturing started, of course, as we know, is in small scale, making individual objects. And then the big revolution coming from serial production, mass production, the famous quote by Henry Ford saying that you can get any color you want as long as you always choose black, illustrating how making large batches was key to unlocking the efficiency in mass production. But I think this statement is quite a nice summary of where we want to go in modern manufacturing with lot size one. We want to make a manufacturing system that is capable of producing single products, but at the cost of mass production. So keep the efficiency of mass production, but still be able to do single product manufacturing. And what are then the key benefits of lot size one? Well, I would say the first topic is efficiency. We learn through lean manufacturing, of course, the Toyota way and so on, that reduced batch size is key to reducing work in progress, reducing waiting times, and minimizing occupied inventory, which is increasing efficiency. Additionally, reduce the risks of overproducing or generating waste by doing small batches, ideally batch size 1. Secondly, and what I personally maybe find more exciting, is the customization aspect. Because here we can increase the customer convenience, we can increase the product competitiveness, we can make improved branding, and maybe most cool of all, make completely new product segments. For example, what you have here, this orthodontics product can bring better teeth health to people who maybe in the past could not have access to it for various reasons. So completely new product segments through technologies like additive manufacturing. So in SICK, we have worked a lot with lot size 1 production, and I can really recommend this video here. If you have a phone, you can take the chance to scan it now. It's a YouTube video on how we work with lot size 1 production at SICK in our facility in Hochdorf. And it both shows you how it works and shows some discussion on how it can be implemented. So I can really recommend this. But now I will focus more on machine vision and applications related to lot size 1. So I like to kind of split in the application space like this. First, I say we have these custom bundles. So for example, when we do shipments that are combined, say that in this example we have fruits. There we are. Fruits in a container that needs to be shipped to the right shop and make sure that it has the right content in it. So this is just counting things, keeping bundles. It can also be optional accessories that need to be verified that they are available in the box when the customer has checked that box that they want that accessory. Another example is medication packaging. It can be a great safety aspect to have pre-packaged medication with exactly the right pills for the right day, so that you know that the person who's taking those pills cannot make mistakes. Next up, we have custom assembly. For example, in this example, when the customer has chosen to have a specific decor in the car, we can make sure that they get the right decor in the right product, minimizing the risk for that we ship the wrong product. Another example is electronics, where a customer can choose a specific design, maybe choose which color a specific component can have, combine them in different ways. This has been done, for example, in manufacturing of video game accessories and things like this. And aesthetic personalization. For example, promotional food items. I'm sure there are many of them here today, but also for celebratory situations, a wedding or maybe a birthday, to get a customized product packaging. We also have electronics. For example, if you order a cell phone and ask it to get custom engraved, to make sure that it's engraved the right way for the right customer. Lastly, I would say custom fit. And here I count, for example, sports equipment. What you see here is custom-made shoes. They can be, for example, companies doing 3D scanning of feet and then generating a specific shoe for that one customer. Can also be medical dental device, as we saw before, or for example fitted furniture such as kitchen or office furniture. So just summarizing a little bit what we have here in terms of challenges. What we see is that we have a lot of different algorithmic challenges. There are many different needs for different applications here. We also have different needs in terms of technology and performance. Is it 3D or 2D? The measurement range can vary greatly. So we see that we need a very extensive span of options here to solve all these applications. In addition, we have challenges in integration and flexibility, because of course integration is a key aspect of lot size 1 production. We need to be able to control the sensors that they check for the right aspects of the product. And with this, I would like to introduce SICK Nova. And at the surface, SICK Nova is just easy and accessible machine vision. We let you solve machine vision tasks in a web GUI, which means that without any kind of special software or training, you can just point and click in the user interface to solve vision applications. There is built-in documentation and help, and it runs directly on the device when you configured it, so there's no need to leave a PC there or anything like this. We have integrated toolboxes with rule-based tools to check measurements. We have OCR and DPM code reading, and you can easily use AI tools to check for appearances combined with these rule-based tools. And of course, you can combine and link tools together to make more complex inspections. We also have I/O control, communication over network to communicate results. And advanced tools for things like managing data and user management and everything you could imagine. So looking at the analysis aspect, like I said, rule-based tools allow you to measure distances, angles, and things like this. And with DPM code reading and text reading, you can easily track items in production. And this means that you can very easily tune these so that they measure exactly the right aspect. From a control system, you can make sure that the device itself is measuring the distance that is valid for this one piece that you're making. Next up, we have AI trained on device. And we have, basically this is AI where you collect, train, and execute everything directly on the device, so you never need to depend on a powerful PC. And we have AI classification, anomaly detection, and object detection here. And they take care of different aspects of the solution space, everything from verifying textures, sorting, to finding defects in surfaces, and counting objects. We also have AI trained with DStudio, which is our more advanced offering, which allows you to still collect and execute everything on the camera, but we have a powerful cloud service that allows you to do an optimized training, and with increased accuracy and speed, do AI classification and object detection. I write coming soon here for object detection, but if you come to our booth, you will see that it's already running very well. There's also a system here in our cloud service for doing data management and for collaborative annotation and things like this that really helps if you're solving larger projects. But connecting back to lot size 1 production, I would really like to highlight these 3 topics. Excellent integration, designed to be customizable, and scalability in hardware and software. And I really think that these are the key aspects of a scalable platform that is needed to support lot size 1 production. So how we chose to do this for integration was specifically that we spent a lot of time making dynamic configuration of how you transfer data. This means that the camera have exactly the right interfaces that it needs for order to set the parameters, for example, depending on which item you're just about to produce, or getting the right information out of the camera. We also have a customized export of user data types or function blocks for world-leading PLC brands, which means that the integration is extra simple, and you get exactly the parameters that you had in your vision analysis moved automatically into the PLC world. Of course, we also have flexible TCP/IP integration options, and you can very easily remote adjust parameters or use the very convenient job system, or image logging options. All this means that you can easily integrate for single batch adjustments of parameters, and you have a highly customized control of the camera. Next up, it's designed to be customizable. Signova, our platform, we decided to make it so that every module, what we call a Nova tool, is self-contained, and our customers can develop their own tools in the same way as we do. So we have the tools called App Studio and a Visual Studio Code extension, if prefer, where you can develop your own modules running in this system exactly in the same way as we develop our module, and they can work together with our modules. In addition to this Lua interface with the 6 sensor algorithm, we also support MVTech Halcon for most of our hardwares, and there you can simply use the Halcon functionality that you might already be using directly in this, and then easily integrate it into this world and using it on all different Nova products. So this means that you can customize and tune algorithms and run them on all different SICK Nova products. And what I think is a really powerful thing here is hiding complexity with customized tool for your use case. If we, for example, take this custom created shoe example, you could easily make a custom Nova tool that has exactly the parameters that are relevant for your shoe production, and you can hide everything else that is just interesting for the vision aspect. And that means that you can much more easily integrate the verification of these custom shoe parameters into the rest of the system, and it's easy for people in your factory to handle. Lastly, it helps you package your knowledge and your intellectual property for licensing and distribution to your customers. So you can choose to use our licensing system to license it out, or use our distribution platform app pool to distribute this to your customers. Lastly, scalability. Scalability in hardware, first of all. Signova began as the platform we use for machine vision on the inspector cameras, from the tiny, tiny sensors that are this big to the big ones that can check entire cars. And after that, we expanded into streaming cameras with computation box, what we call pico and midi cams. But what we did then was to expand into 3D. And this was always the goal, to bring everything into one big platform. We started Visionary T Mini, which is a time-of-flight camera with really great ambient light resistance. And we also used the Visionary S, which is a stereo camera and also gives you 3D and color information. After this very year, we released support for the Ruler 3000, which gives you these excellent detail images you see in the background for really great laser triangulation image quality and great service inspections. And lastly, the LMS 4000, which is just really large-scale line scan time-of-flight 3D images. Additionally, in scalability, we have scalability in software. Because wherever you start here, you have the flexibility to change. So if you start out, you can choose a smaller toolbox of tools if you don't think you need all the tools. But then you can expand. You can, for example, try the AI tools even without the AI license. And if you see that you actually need these for your use cases, then you can choose to get this license and continue using it. We also have the flexible cloud service associated. So the unified vision platform provides flexibility to change camera technology and performance or form factor. It provides the flexibility to change toolset based on your own needs. It provides consistency across all devices for different algorithms, including AI. And as we've seen, that is necessary for the lot size 1 production. And compatibility with line integration or customizations that are then compatible across all these different devices and all these different technologies. With this, if you want to know more about this platform, I would again direct you to this QR code and scan it. It's an excellent tutorial series that I would recommend watching. I have a slide for questions, but looking at the timer, I think we maybe don't have time for those. So I will stay over there after the presentation, and you are more than welcome to come ask me whatever you want relating to this. And after that, I will be, and my colleagues will be in Hall 10 at booth 10D41. And come by and check out what we're offering and discuss lot size 1 production and machine vision in general. Thank you so much for listening to my presentation.
Victor, we do have time for questions. Yeah, no problem. Okay. We have a few minutes for questions in case there are questions. Otherwise, yes, we will be happy to follow you on to your booth and ask some more questions. But at least answer me this: where do you think? Pretty much the same question that I asked the previous speaker. Where do you think is a possibility to get even better?
I think the direction we're going here is integrating more and more vision technology into this one platform. And I really love to see more and more come together, as we've seen only in the last few months. Mm-hmm. And I think we will see the same thing, even more technologies, even more form factor consolidated into the same platform, so that you know that you always have a path forward within this platform without having to relearn, without having to redesign integration, without to redesign customization.
Sure, yes. And have you already partnered with camera manufacturers whose products you can already integrate into the platform?
Today we have focused on our own cameras. There's no technical limitation per se for anything else, but we want to make sure that what we are offering is really working 100%. We want to make sure it's reliable, and we want to make sure that it fits into one highly functioning ecosystem. Okay. So that's how it is today.
Thank you.
Thank you.
So we go to the next one, which is, the topic is pretty strong. The cloud will deliver end-to-end AI solutions for machine vision users. That's a high promise.
See you. Yeah.
So Donato Montanari will present the topic for you, and then maybe we have some challenges in the end thrown at you.
All right. Hello, everyone. Thank you for having me. My name is Donato Montanari, and I run the Machine Vision business unit at Zebra. And in Zebra, we've been in Machine Vision for not so long. And one of the advantages when you're in something not so long is that you can really start thinking ahead of the pack. You have nothing anchoring you down, right? And for us, thinking ahead of the pack is being very much related to deep learning and AI. And I've been in the machine vision business for a very, very long time. And one thing that I've always been excited about is AI. And one thing that has not really worked very well in machine vision has been AI. We as an industry have been very late in AI. And if we ask ourselves, is AI working in the machine vision context? Is deep learning working in terms of doing quality control? The answer is, I don't really know. There are definitely a lot of applications that we do today with deep learning and with AI. Particularly in surface inspection, particularly in looking at some kind of foods. There are really a lot of things that we can do today and deploy successfully with deep learning and AI that we were not doing a few years ago. But in Zebra, we are somehow obsessed with customers and voice of the customer. So what we did, we actually went out and organized a very structured survey of the world of manufacturing. And we asked the questions, are manufacturers actually using AI, and are they deploying successfully AI? And it's a kind of an interesting result. And here are two examples, two different countries, UK on the one hand and Germany on the others. And you may say that Germany is very traditional, very conservative, and UK is less traditional and less conservative. But what is interesting is that if you look at the UK, 25% of the people say, I don't really care too much about AI. I don't see how that's going to help me, right? And you can relate to that. If you're doing metrology, if you're measuring from A to B, you don't really need AI, right? 40% of the people in the UK, they are actually very satisfied on how AI works. If you look at Germany, it's kind of the opposite. You're 35% of the people in manufacturing who say, no, really, I don't see why I should move to AI. And you have a 25% who's actually very happy with AI. But what is interesting is that in both of these sort of extremes, you have 20% who are saying, yes, I'm using AI, it's great, but it could be better, right? I tried it, yes, I can do this, I can do that, but hey, after a while, managing all those models and having 7 factories with 22 models, and I don't know which one runs on which machine, it's challenging. So really, how can we do better with AI? What are the challenges that if you are implementing AI for a living, you're in a factory environment, you're facing every day, right? A lot has to do with how you collect the data, how you train the model, and ultimately how you do the annotation and managing all of these models. And it's not as simple as it looks like. There is a lot of science related on sampling the data, having balanced train sets, and applying those models and deploying them consistently. And today, everyone does it in a little bit of a different way. Even within a large organization, you have different centers and different development teams that are doing it a little bit differently for their specific use case. So we think that the solution for this problem, it really is cloud training. And what we mean by cloud is basically a bunch of servers that are physically located somewhere within the organization or outside of the organizations, and where everything runs on those servers. Where if I were to break down what deploying a model consists of, which are the blocks up there, they are all running on the same servers. They're all running on the same cloud. So it's a single repository of your data where several different teams can collaborate and develop a model together. They can revision a model together. They can decide where to deploy it, how to maintain it, and how to update it. And this concept of collaboration, it's very, very important, particularly as the organization scales, and particularly as the organization is large. Right? If you have one line and one model and that's all you do, is one thing. But if you have several factories, several lines, thousands of SKUs, then the level of complexity is very, very high. And try to manage that locally is probably not a very good idea. Now, obviously, the number one question when you start talking about the cloud is the security. And in machine vision, we are a little bit paranoid about this. But in other industries, they've actually solved the problem. And there are companies that specialize in that. And again, building an ecosystem certified for that is a very important first step. Talking about encryption during uploads, encryption for storage, private cloud instances, all of these things that in our world, they seem very complicated. Actually, they're not. Some other people have figured it out. We just have to take that and deploy it in our industry. And by doing that, we have the infrastructure, and with the infrastructure, we can build. So, is that something that every company may want to do themselves? Probably not. Probably, using an established ecosystem, using an expert who has put this together is a much better way to approach it. Because again, it's not exactly easy. So if we look at really what this cloud training is all about, is about saving images in a repository and be able to annotate them. Annotating these images for machine vision is a little bit different than annotating images in other applications. If we look at for instance, autonomous vehicle, where there's a lot of AI, right? It's very easy to say, hey, here is a tree, here is a pedestrian. You don't really need a lot of accuracy. But when you're annotating a cogwheel or a very specific, precise piece of machinery, it's essential that you have the tools to go and really draw around that, almost with millimeter or micron accuracy. And having those tools is very, very important. And the more accurate this annotation is, and the better your model is going to work. Annotations are not necessarily part of the image. They are part of how the process works. And so how do you move annotations around, like what formats you support, like JSON and so on, is also very, very important. This is, again, sort of an example of how this physically look. This is a connector, and you can see on the one side there is a missing cable. And again, this is how we annotate it. The other important thing is you annotate for what? And it really depends on which models you want to train on the network. And there are all sorts of different models that are coming into the industry, and having all of them as your disposal as tools is very, very important, right? Because some things you do with segmentation, some things you do with anomaly detection, and eventually you want to be able to classify. And then, last but not least, you have to be able to test and validate your model, which again is something that if you have an environment like the cloud to be able to do it, and when you have several stakeholders be able to participate in the same validation, in the same model development, then the model is much more robust and can be deployed in several different facilities instead of having every facility deploying their own model. And finally, you have to put this on an edge, right? It has to run somewhere. The inference typically in manufacturing doesn't run on the cloud. And so having the ability to choose your hardware and having the ability of being hardware agnostic and choosing the best hardware for the best model is very, very important. Right. So we talked about the cloud, the infrastructure, the product. But the most important thing when you put things together is actually the team, right? And you need to be able that having different team functions and different skill set to participate to this. And so your cloud infrastructure need to be able to manage this. Need to understand, who are the people who can annotate, who are the people who can actually change the algorithms, who are the people who can deploy the algorithms. So having these permissions, having this system already in place is very, very important. So this is what we do at Zebra, and we will be very happy to go more in detail. We are somewhere over there. I think we have the biggest booth in the event. Just not to brag, but I think it's actually a true statement. So please come see us. Thank you.
Do you have any questions? Any questions for Donato? I have a question.
You always have questions.
Yeah, always. So human beings are annotating these things. So is there a future where the annotations will also be done by the AI and the human beings will only be saying, yeah, you've done a right job and you've done a wrong job here? And from there on, another learning cycle is starting?
I don't know. That's a different question. I think what you'll see is AI being deployed to help the annotators.
Yes.
And that's something we are working on right now, where if I annotate one image, right, and I find this very little detail, and then the next image pops up, and it was exactly like the previous one,
yes.
AI can tell me, hey, it's the same as,
yes.
Do you really want to annotate it again? Or I'm just going to say it's the same, right?
Auto, yes.
So I do see a lot of AI or generative AI being used to help the annotators, but in quality control at the end of the day, there is a lot of knowledge in the quality engineer who can look at things like, no, this is not, right? And that knowledge, I think, is very hard for a machine to really master. One other way where I think AI could be helpful is actually in digital twins, right? So if I have a CAD model and I build the neural network on the CAD model, and then I use anomaly detection, I think that's also very, very powerful. I think that it's definitely an area where today there is a lot of research going on.
Perfect. Thank you.
Right.
That was
Thank
my
you.
only question. The rest of the questions I can ask at your booth, right?
Thank you.
I can go to your booth. Thank you for listening. We'll go to the next session.